Hi everyone, I am T. Ramesh, Assistant Professor, Department of Mathematics, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. In this lecture video, we are going to discuss about the topic analysis of variance. From this, we discuss the case study on F-test. Introduction. F-test is find out whether the two independent estimates of population variance differ significantly or whether the two samples may be recorded as drawn from the normal populations having the same variance. So we calculated the F ratio test by S1 square by S2 square. That means S1 square is the variance of the first data. It is calculated from sum of x1 minus x1 bar the whole square by n1 minus 1. Similarly, the variance of second data, that is S2 square, is sum of x2 minus x2 bar the whole square by n2 minus 1. You noted that which variance is greater compared to the other one. So we take as it is in numerator. Therefore, the F-test is always in numerator. In this F-test, the numerator is always larger estimate of variance and the denominator is always smaller estimate of variance. So how calculate the degrees of freedom? So degrees of freedom for sample having the larger variance is n1 minus 1, number of data minus 1. Similarly, the degrees of freedom of sample having small variance is n2 minus 1. So the calculated value of F is compared with the table value at a 5% level or 1% level of significance. If calculated value F is greater than the table value, the F ratio test considered significant and the null hypothesis rejected. On the other hand, if the calculated value F is less than the table value, null hypothesis accepted and is inferred that both the samples have come from the populations having same variance. So the two samples were drawn from two normal populations and their values are A is given is 66, 67, 75, 76, 82, 84, 88, 90, 92 and B value is 64, 66, 74, 78, 82, 85, 87, 92, 93, 95, 97. So test whether the two populations have the same variance at the 5% level of significance. So null hypothesis, the two populations have the same variance. So applying the F-test, it is that the large estimate of variance divided by smaller estimate of variance. That is S1 square by S2 square. Here, first we find what is the average, sum of all the value divided by number of data. So in the first one, it is 9 data. Therefore, 720 divided by 9 is equal to 80. The mean of second data, that is X2, is 913 divided by 11 data is equal to 83. So we calculated this value. So X1 and its average mean difference from arithmetic mean is 196, 167, so on, and the sum of all the values becomes 734. Similarly, we take the B data and its sum of the deviations, sum of square of the deviations from each data in the average is 1298. So we calculate all those things. So now the variance of first data is 739 divided by n1 minus 1. That means 9 minus 1 is 8. Then we get 91.75. And the second variance value similarly same, 1298 divided by 11 minus 1. That is 129.8. So F-test is large estimate variance divided by small estimate variance. That becomes 129.8 divided by 91.75. So using this we get 1.415. The degrees of freedom of first value is 10. Is 10. That is 11 data. So 11 minus 1 is 10, and the second data becomes n2 minus 1. So we get the degrees of freedom value of F-test at 5% level is 3.36. Since the calculated value F is less than the table value, therefore we accept. Hence, it may be concluded that the two populations have the same variance. So that is a F-test. So F-test purpose, there is significant difference between the variance of the two data using large estimate of variance divided by smaller estimate of variance. So using that, the degrees of freedom The first value n1 minus 1. The second data value is n2 minus 1. Using the F ratio formula, we get we check whether the hypothesis accepted or not. But in this case, we accept the H naught, that we conclude that the two populations have the same variance. Thank you.